Okay, welcome. This is a video or series of videos on doing pixel, smart RGB lighting at your home or business. And it uses technology called DMX controlling. And I put the video together because I get quite a few questions from neighbors or friends on how to do it. And as well, my daughter is studying entertainment technology at a university in Pennsylvania, and she's going to be learning some of this stuff. So I wanted her to have the opportunity to see how I do it on our very own house, so she gets a little bit of an advantage going into that course. This is my house, and we're going to be going through a series of things with you. I have a couple of slides for you. This particular video is the introduction. So what better way to introduce you than to show you the house in action? So on this house, on the trees, the bushes, the junipers, I have standard net lights. They're LED net lights. They're not on my controller system. But the floodlights that are shining on the trees and on the walls and on the columns in the front entrance are all dumb RGBs. So there's two of them here by the garage. There's two of them under this area. There's two of them at the columns, and there's two under this bush here. Each pair of dumb RGBs is wired to a controller, which means I can control these two at the same time. I can't control them individually. So if I make them red, both are going to be red. That's what the RGBs do, the dumb ones. On the house, we have smart pixels. So smart pixels on the house, every single individual light can be programmed. Now, every light that you see isn't one LED. It's actually three: a red, a green, and a blue, RGB. And by mixing intensities of any of those three colors using light, you can produce anything from white to black and everything in between. On the tree trunks down here, I have another form of a smart RGB called strips, or they call them strips or reels. I have 1,200 lights per tree. Each light is, again, three little LEDs, RGB, and these can also individually be programmed. At the bottom of the tree, you'll see a Christmas present. It was Christmas time. We wrapped the box. We covered the controller and the power supply. So under that box at the bottom of each tree is a controller and a power supply, because these things don't come with power. You have to buy the power supplies and inject the power along with the data. So what's happening is that controller is getting commands over a network that ties into my home network. That I have a laptop sitting on that network running software that sends data to each one of these controllers and tells them what to do with their lights. The controller gets that command and then formats it into DMX and feeds it onto the lights on the tree. So as you can see, it's doing some funky patterns here, but it's a good idea to get an idea where we're going to be doing and what you can do with this. Now, my house is not that extravagantly decorated with these. You can do shows where you animate it to music. You can have other things, fog machines, all sorts of stuff turn on and off with DMX controls. You don't just have to do lighting, but lighting is one of the common things done with it. So every single pixel in here, with the exception of the dumb RGB floodlights, has an address on my network. And we use software to control what it's actually doing, and we try to get them coordinated so they're doing things that it looks like a nice effect. So let me stop it here at the tie-dye. By the way, one of my favorites is the tie-dye. And what we're going to do is understand that I have these controllers down here. They each run a network cable back to the side of my house here. And there's two controllers back up in here towards the house that are hidden in the bushes that control the house and those dumb floodlights. So we'll come back to that in a little bit. For now, let's jump over to an introductory slide. So excuse me one second while I figure out where that is. Here, it's under here. So this is not the one I want. I don't want to give you something difficult first. We want to start you out at something simple. So here we go. So this is just the overview video. We are going to be teaching or explaining DMX. DMX is a control protocol for controlling devices, in our case, lights. The other term you see there, E131, when we have our laptop, as you can see down here in this box, and it's sending its stuff to these controllers to control the lights, instead of having long DMX wires, we're going to just send it over a standard network. So we're going to use our home network here, the same Wi-Fi you use to get to the internet. that network is referred to as an Ethernet network in your home, whether it's Wi-Fi or it's not Wi-Fi. It's wired or both. So when we connect the laptop to the network, mine is connected wirelessly. And when I connect the controllers to the network, those are connected through a wire. They're all connected together. And then what I'm going to do in this software is I'm going to send DMX commands or instructions for the lights on what to do. And when I put it into an Ethernet packet to pass it from here to here, that's called E131. And that is it's basically a standard at this point, if not a formatted standard, a de facto standard, is the fact that everybody's using it, is that you get the control software to talk to controller over Ethernet. From here, it just talks straight DMX to the lights. So E131 is DMX commands inside an Ethernet packet, and then this is just straight DMX. The topics we're going to cover here include showing some of the light examples, types, visiting some of the websites, seeing some of the controller types and explaining smart versus dumb and hybrids, going through some of the wiring. The dumb ones use 4 wires, and why is that? And then the smart ones use 3 wires, and why is that? We'll also talk about how they get color, how the addressing happens for both types of networks. And then we'll show you some of the configuration in my home so you get an idea how it's configured and what the interfaces might look like when you go to configure your own. So in the overview here, I do want to tell you and jump to a setup of my home. So let me get to a picture of my home. So this is a picture of my setup that you just saw in the video. I have 3 trees, 1, 2, 3, and each one has a controller underneath it, and it has outputs. Now you can just think about these outputs as wires for right now. So a wire comes out of that box, it goes to a ribbon of those lights, and then it's actually chained onto a second ribbon. So there's 2 ribbons of lights off of this output, 2 off of this, 2 off of this, 2 off of this, for a total 1,200 lights. The other trees work exactly the same way, different controllers. And then the controller up here has the 75 bigger lights that go over the garage in my house, and these are the 150 that go over the higher part of my house. And not drawn here, but between these 2 boxes, there's an actual wire that runs from this controller out of its box into another controller called a dumb controller. And that dumb controller is the one that controls my floodlights. And remember, I told you that they're on the ground, and there's 2 paired together. So out of this output, there's 2 floodlights, one into the other. And the same thing here and the same thing here. And that's pretty much my setup. These wires that come out of these controllers are standard Ethernet type wires. Mine, I think, are 120 feet. And the 120-foot wires run across my yard, and I kind of bundle them together and put little flag markers on them so nobody runs over them. And they go around to the side of my house, and they go in through a hole I drilled in the side of my house. And I know that kind of sounds funny, but let me show you what I mean by that, because I put on my house a box like this, which out the back is a hole, and I pulled a hole in the wall, and I put a pipe through it that's about 1 foot long, and I sealed it, water sealed it, so it's watertight and weather tight. Then out the bottom, there's another hole. This hole at the top's plugged. There's a hole at the bottom. Actually, mine has 2 holes in the bottom. And what I do is I take those wires and I run them up underneath, and I run them into here, and then I stuff foam in here so it's sealed so no air gets in. And then when I'm done doing my display and I remove the wires, there's actually a plug that you screw in here, and you plug these up permanently for the rest of the season, and then you can use it and leave it on the side of the house. So this wasn't too hard to put on. Just make sure it's weather tight, and you don't want anything getting in there rain-wise or air-wise. So, but this is my house setup. Let me go back to our other diagram. And this is a basic setup. So for the overview, I'm just going to complete this particular page and a couple of these slides up here to show you examples of what these devices look like. Then in the next video, we're going to start to talk about dumb versus smart pixels. So the way this whole system works, if you break it down to the simplest parts, you have your lights or your effect. It could be a fog machine, it could be something, but in our case, it's lights. I drew a little long rectangle here to represent the ribbon lights. So on the end of these ribbon lights, when you buy them, the most common thing I get calls from is the fact that there's just wires hanging out here. There's no power supply plug things neatly. It's just wires, and a lot of times you're going to have to solder those. So there's going to be a bunch of wires, depending on the type of a light this is. There might be 4 or 3 or even more, 5 or 7. In my case, I'm just going to cover the 4 and the 3. And into those wires, you have to produce or provide electrical power. And then you have to provide control or commands or data to tell the lights what to do. So the power supply that you have to get or buy will feed power into the lights. Then your controller, which I'm going to show you illustrations of both of these in a minute, will feed the commands into the lights as it receives it from the software. So over here we have the controller. It's connected directly to the lights, but it's also connected to the Ethernet network. And it has an address, so the light control system knows to send it data when it wants to light the lights that are connected to it. And then it converts that into straight DMX and sends it this way. When it's going over this network, it's E131. When it's going over this network, it's DMX. Now, the power supply also has to supply some power to the controllers. The controllers will need power to run. So in my case, my controller and my power supply are in one weatherproof box. And the power supply powers the controller and the lights at the same time, which is really convenient. Probably one of the better ways to do it. And of course, the power supply just plugs into the outlet. This power supply is 12 volts on the DC side and regular 120 on the AC side. AC is alternating current. That's what you typically have in your home, and that is 120 is what typically comes out of an electrical outlet in the US. The DC is direct current, and if you ever seen one of those blocks that you plug in the wall, the bricks, that are like these black square things that you plug in, and then you plug a smaller adapter into something that you're trying to power, that's an AC to DC converter. So it's all just in one box. So those are the fundamentals. Let me show you the simplest setup you can buy, probably on the internet for 20 bucks. Now, this is a reel of, 5 meters of ribbon. That actually looks more like less than that, but it comes with this little controller that you can see it plugs in here. You can see this plugs into a power supply, and that's DC side. And then the outlet here, actually that's a European, but imagine that was a US one. That would be your AC converting the DC, 120 volts down to 12 volts, into here to power it. And this little thing here is just a remote control. It's an IR sensor, and this is infrared, and you push red, and then this whole reel will turn red. So this is a dumb controller. You can't actually tell each individual light here what color to go. It won't tie into a computer. You literally have to point this at this to light this. So, but it's the simplest example of, hey, you need a power supply, you need a controller, and you need your lights to have both data and voltage so they know what color to go. So I like that as an example when you're looking at this to understand the simplest version. So let's look at some of the more complex versions of those devices. So first thing we'll look at are different types of lights. So you have smart pixels at the top. They'll call them smart RGBs, they'll call them pixels. What it really means is each light can be individually controlled. Color, intensity, on, off, such like that. Each pixel that you see here, like for example, this white one I'm pointing at, and it's kind of white, but there are actually 3 LEDs there, a blue, a red, and a green. In the proper order, it's red, green, blue. And red, green, blue are the primary colors of light. So when you mix them at full intensity, each one, you should end up with white light. And then if you vary intensities of each one, they come out different colors. Fortunately for us, we have software to control this. We can just say, I want this cool purple color or pinkish purple color, and boom, it figures out the intensities for us. We'll see more about that later on, but remember, each one of these lights is actually 3 LEDs. Same thing with these bulbs on the right. These bulbs on the right are exactly the same things as these pixels on this ribbon, except they have a big piece of plastic on them to diffuse the light and kind of look like original traditional Christmas lights. And by the way, these are fantastic. I get these from Holiday Coro. They're called Brilliant bulbs, and they are wonderful. And then these little nodes down here, I don't actually have any of these. I was thinking about playing around with some of these this year. These look a lot like twinkle lights, and again, each one of these has 3 LEDs in it. These do have multiple connectors, all of them. So you go in from the controller into a wire, then out to another set. You can't do that infinitely because you only have a certain number of addresses and a certain number of power per output, but we'll talk more about that later. So these would be smart pixels. Down the bottom are more what we refer to as dumb RGB strips, where And I use this green illustration as my primary illustration because if you output tell this string to turn green, everything in here turns green. And if there's anything looped onto this beyond it, they also turn green. You can only address the entire string. Same thing with this floodlight, same thing with here. The difference between these two isn't just the pixels or the lights. The wiring is different. How they work is different. How you send them controls is different. So you can't convert an RGB dumb to a smart pixel and back and forth. You can kind of think of these smart pixels. They actually have little protocol chips. I'm trying to remember the number. It's WS2811 or 2911. I can't remember the number exactly. It's later in my notes. But these don't. These actually use voltage in 4 wires. These use 3 wires where data, it's one of them is a data channel. We'll show you that as well. So these are the different types of lights, and we have different types of controllers. And I'll show you a couple. The simplest one was this guy, right? So this was a controller. But I'm going to show you the ones we traditionally use for doing shows are the two at the top. The left with a yellowish lighter green and the medium green here on the right. These are typically a smart controller here on the left, pixels, and a dumb controller here for dumb RGBs on the right. Down the bottom of the pink, just to make somebody see what the cheaper version for the outdoors looks like, and I don't really know if this one's outdoors or not. You might have to seal this up, is a cheaper version of this dumb RGB here. So in this dumb RGB down the bottom in the pink, the power supply here, you'll see the wires hanging out, typically is about the size of like a power strip or a surge suppressor. You'd plug it in, then you'd run these wires under this cover here and wire it in. Out of here, you'd wire your lights, and then you could either dial the color intensities or push buttons on the remote. Now, this is the simplest version. The reasons it's included is to show you the simplest setup. If you want to do something cheap, of course, it's not going to tie to a computer, and it's not going to tie to automation. You're going to have to set the color. But if I was using it for something like a stage effect where I only needed one color, but I needed to be flexible for the next show, or I'm doing under-the-counter lighting at my home, or I'm going to do soffit lighting, or I'm going to do a lighting in a bar, these are great because you're not going to usually typically change the colors every minute. You're going to change them for that evening or one party, and you're going to leave them that color. So they actually work out really well. So this would be the power supply. This would be the controller, and you'd buy the lights as well. In the lighting show stuff that we're doing with the house, we use these two. I actually have one of these, and I have 4 of these. And what these things do is I actually added power supplies above them, though you buy them separately. I put them both in the same gray box, and that's the illustration at the bottom right is an illustration of a controller board with a power supply in it, in a weatherproof box with the pigtails. We call these pigtails hanging out. These are wires that wire to these green terminal blocks, and they come out and they have these little cool weatherproof screw-on adapters, so you don't have to do any special type of connections. You can literally plug them in, screw them down, and they're sealed up weather tight. So I have actually 5 of these, 4 smart ones and 1 dumb one. So what do these controllers actually do? Well, they wire into the power supply. That's where the controller gets its power from. Then it also passes controller to each one of these little outputs called SPIs. Here's where you're going to be attaching a pigtail that ultimately runs to a set of lights. Might be 1 string, it might be 2 strings. It really depends on what you're trying to do. If they're dumb RGBs, you're going to use this guy. If they're smart RGB pixels, you're going to use this type of guy. These are more expensive. I have 8 put outputs. This is a 16, so I only have 1 row of these. And a 1 row 16 with a power supply is probably $250. These are a lot cheaper. And again, it all depends on how many outputs you're getting, what size power supply you buy. So when you buy the power supply, you've got to feed enough for this controller, which isn't much, but you've got to feed enough power to drive your pixels. So let's take a quick look in this overview of how you might calculate that. The reason I like to show you this is because these vendors, I'm going to use Holiday Coro, they do charge you to help you with this. I guess, and I don't blame them. I mean, they get a lot of calls where people want to spend hours on the phone trying to figure out how to do this, but then they don't want to spend the money. It's not cheap to get in this business. But I've actually paid to have them on the phone, and I don't want to criticize them too much, but it wasn't exactly satisfying, the experience. It got me started, got me what I needed, but it wasn't really, I felt like it was well worth the money. I probably would have been better off watching some videos, and hopefully somebody like myself made a video that I understood and could get started with. So Here what I'm going to do is I'm going to go to a controller. Actually, let's start with a bulb. Let's just go to a smart strip or ribbon or tape. So I'm going to go to one of these. Now, when you buy these, they have different lengths, okay? So this is a 5 meter, which is 16 feet long, 12 volt unit. It's that 28 WS2811 protocol. These are smart pixels. Strip of 30 LEDs per meter. The kind of 30, the LEDs tell you how many LEDs per meter. The pixels tell you how many pixels per meter. So when you look at 30 LEDs per meter, but only 10 pixels, that means 3 of them are going to light the same color. And you can see that illustrated here. You got 3 red, then 3 green, then 3. If you want each and every one programmable, it should be a 30-30, which is, where's the 30-30? There they are. So 30 LEDs per meter and 30 pixels means every single light is a pixel. Let's go into this guy. It's 47.49 on his site this year. That's what it looks like. And basically, I want to see the information here. So you see it's 12 volt. I have to know it's 12 volt. It's 72 watts per meter, but I'm not really going to cut it. So it's 36 watts per 5 meter roll. So this one roll uses 36 watts. So on the controller, if I have 2 pixels strips, I have one, and then it goes into a second one, and they're using the 36 watts, that's 72 watts of output I need to be able to support on that. And if I do that 4 times, that's 72, 140, 150, 300 watts or something like that in total. So let's take a look at the controllers. His web page. He's got to do something here better with the menu. It's a little bit difficult to navigate on some boxes. So I'm going to go to a smart controller, and let's just take this guy. It's a standard 16 output, smart pixel, his version 3, which is a new version. This case is called Alpha Pix. And we can actually look at the specification down here. And we can take a look at the power requirements. So he has a maximum wattage of output per output of 60 watts. So 12 volts at 60 watts. It doesn't seem right, but that's what it says, which would be a problem for putting multiple strings on there. He does have a table here. So he actually shows his strips, 30-30, 5 meters, with power injection. He says his system will handle 2 strips per output. Maximum of 36 of these strips per controller. So, okay, great. His math doesn't add up. If it's 38 watts per, I think it was 38 watts per strip, that's 72, but he set up here only 60 some, but he says it'll handle 2, and it actually does. I know it does because I have 2 strips per output. So when we're looking at connecting our strips here on these outputs, we can run 2 strips, 2 more strips, 2 more strips for a total. So when you're kind of thinking about doing this and you're thinking about buying something, if you buy it too small and then you want to add to it later, this is only going to output a certain amount of power. And let me just use his site since we're on it. There's other sites as well. So I'm going to go to power supplies. You can see these power supplies. This one outputs 350 watts. This one 400. So they're $23. They're not too expensive. But it's an output of 380 watts. 12 volt. So when you're putting it in your box, you're going to have a total of 380 watts to work with, and you won't be able to power any more lights after that. So if I had a 16 like this, I might want to get a bigger power supply. In my case, I have an 8, which it's plenty of a power supply for it. So that's all we're going to cover in this video of the introduction, and that hopefully gives you an idea of some of the pieces, some of the components. when you go to these websites, let me take you to a different one. Lightorama. Lore is one of the softwares I use. Lightorama software. I use their software. I don't buy all their gear, but you can go to their website and you see some of the lighting effects that people do. These are individual pixels. These are RGBs, dumb RGBs, where they're all the same color. So let me just go ahead here a little bit farther. These are smart pixels inside these arches, smart pixels on the house. These are dumb RGBs on the trees. As you'll notice, the string in that example there, each string never changes. It only changes to one color on the string. So pretty cool. And they've got some controllers and pixels and sequencing software here as well. Other types of do-it-yourself projects they sell some of this guy here. Originally started his business, that's why it's called Holiday Coro, because he would use corrugated materials, plastic corrugated materials and stuff like that, and put lights in them to make them look cool. So you can get that sort of stuff as well. Before you go hog wild with this, I would consider trying a small implementation and then adding to it later down the road. And the one thing you're going to want to do is when you buy these products, the products are mostly made overseas. They get shipped over. I always run into weird problems like the lights aren't quite the right color, or when they wrap them, if you guys look at this is one of the ends. And it's kind of like this screw-on end, and they wrap them so tight that when they're warm, they warp. And I bought like a whole bunch of these. I had to heat them up and actually reshape them by screwing them onto another end. I had to heat them with a propane torch real fast not to get them too warm. And I thought about returning them to the guy, and I thought, it's going to be a nightmare. So I just kind of did that myself. There's other products they sell up here, including a lot of the wires and stuff like that. He sells, and a lot of the companies sell these kind of networking cables and stuff like that. They're not too bad at pricing to get a 100-foot cable for $15. If you go into Home Depot or something, you're going to pay $50 for that. But some of these other things here, like this little $16 hub, you can go to Best Buy and get something like that. And then they've also got some of the pigtails, and that's not the one. Let's see here. Extension wires, sonic shrink wrap, private enclosures. Let's just see the extension wires and stuff like that. The shrink wrap stuff like this, it's nice to get this, not necessarily clear, but if you want to get this really cheap, go to Harbor Freight. They have the best pricing on things like zip ties, Velcro, heat shrinks, stuff like that. You can get it for like $2. You get like hundreds of pieces of equipment there. Let's see here. The waterproof enclosures are here. So he sells the boxes of waterproof enclosures. What's nice about this guy is he'll actually build you the whole unit inside the box, which is what I paid him to do. I was like, I could do it myself, buy all the pieces, but when you buy all the pieces, by the time you get it right, it was actually a little bit cheaper getting it done. Last thing I'll finish with is these controller boards here do have this little chip on them, and I don't know if you can see this chip I'm circling right here. This has got 4 of them. And these are like $2 or $4 each. And if you get some weird electrical thing, it can mess these up. So it's always good to order a couple extra of these so that if you have a problem, you can actually use a plastic tweezer or something and pull that out and put a new one in, and it just works. We'll cover in our next video, we're going to go through the dumb versus smart RGBs. So this was the overview. On to the next.